In the previous two subunits, we've looked at two-dimensional differential equations. We generalized the idea of a phase line to a phase plane, and we saw that two-dimensional differential equations are capable of somewhat more interesting behavior than 1D differential equations. In particular, 2D differential equations can show cycles or oscillations, and sometimes those oscillations are attractors. In this subunit, we'll continue our journey into higher dimensions by looking at two-dimensional iterated functions. We've looked at one-dimensional iterated functions a lot, mainly the logistic equation, and that's one-dimensional because we're keeping track of just one variable, usually x, over time. In this subunit, we'll look at two-dimensional iterated functions where we're keeping track of two variables at a time. We'll see how that works and how to visualize orbits in two dimensions. The two-dimensional iterated function that we'll look at is something known as the Hénon map, and it's given by these two formulas. So this is an iterated function like the logistic equation, except now there are two variables, x and y, and so an orbit or itinerary would have be a list of two numbers, not just a list of one numbers. So this says that the next x value, to get the next x value, you take the current y value, add 1 to it, and subtract axn squared. A, in this case, is a parameter, and b is a parameter too. And then this says that the next y value is just b times the current x value. So in order to get numbers out of this, we need to choose values for the parameters a and b, just like we needed to choose a value for the parameter r in the logistic equation. For this example, I'll choose an a of 0.9, and b will be 0.3. So those are my parameter values. We also need to choose initial conditions. There are two initial conditions now because there are two variables, x and y. For my x initial value, I'll choose 0.2. And for my y initial value, I'll choose 0.4. So let's calculate the first iterate. That would be x1 and y1. So to do that, we just follow the equation. The equation determines the next value and the next value and the next value and so on. This is, as usual, a deterministic dynamical system. So let's see. So x1, that'll be y0 plus 1 minus axn squared. A is 0.9, and xn is 0.2. And for y0, I should have put in 0.4. I guess I'll write this again. 0.4 plus 1 minus 0.9, 0.2 squared. Okay, so let's do this on a calculator. 0.2 squared is 0.04. Let's multiply that by 0.9. 0.036. So this becomes 0.4 plus 1 minus 0.036. And now let me do this out in a calculator. 0.4 plus 1 minus 0.036 equals 1.364. 1.364. So that's x1. And let's also get y1. All right, we need to keep track of two variables now, not just one. And I think I have enough room to do this. Let's see. So this equation tells me that y1 is b times x0. B is 0.3. X0 is 0.2. So 0.3 times 0.2, you could do that in a calculator or in your head, depending how nimble mentally you're feeling, and this would give you 0.06. So I'm just following the rule, like we always do with iterated functions. We're just applying the same rule over and over again. In this case, I just did it once, and I got that x1 is 1.364, and y1 is 0.06. So these two taken together are my initial condition. This is my first iterate, x and y. So as you probably guessed, we'll want to do this many, many times, and soon we'll turn to a computer to do this. But before we do so, I'll suggest doing the quiz that follows this lecture, just to make sure you see how this two-dimensional iterated function business is working.